In January 2022, leaders from Intel shared the stage with Ohio State President Christina Johnson, Governor Mike DeWine, and others to announce a $20 billion investment in the construction of 2 new computer chip factories in Central Ohio. Intel shared 3 reasons for why they chose Central Ohio to expand: land, infrastructure, and talent. The Ohio State University College of Engineering plans to provide much of the talent required to fill roughly 3,000 high-tech jobs at Intel. This past September, Intel awarded 2 grants to Ohio State, a combined $4.5 million, to prepare a highly skilled and diverse semiconductor industry workforce and to expand development of semiconductors and next-generation device technologies. I'm joined today by Steve Ringel, Distinguished University Professor of Electrical and Computer Engineering and Associate Vice President for Research, who also serves as Executive Director of Ohio State's Institute for Materials and Manufacturing Research, home of the new Center for Advancing Semiconductor Fabrication Research and Education. Welcome, Steve.
Thank you very much. It is really a pleasure to be here today to talk about all the amazing things going on in semiconductors at Ohio State and at Central Ohio. It's really been an extraordinary ride, and we're looking forward to continuing well into the future.
So this is great. Okay, I'm going to start with an easy question. I know we just threw a bunch of words at people out there, but semiconductors. We've kind of heard about it. We might know about it, but a lot of people don't. So why do semiconductors even matter?
Sure. So that might be an easy question to ask, but that's a big answer to unpack. So what I'm going to do to answer this question is just to start by telling folks what actually is a semiconductor, because that'll help understand how they're used and why they're important. So when most people think of semiconductors, they're thinking about what you look inside of your big computer box or you crack open your cell phone case and you see those black packages, and we think those are semiconductors. Okay, those packages or packaged chips, inside of them contain small pieces of silicon that inside of the silicon material has billions of silicon transistors that are integrated together in special configurations. And it is the configuration of transistors in that semiconductor silicon that actually is the chip. The way that these work is we're able to control the flow of charge between transistors in that integrated circuit such that we can turn charge flowing on and off hundreds of billions of times per second to allow different functions to be performed and different applications to be controlled. There are many kinds of chips around in your computer, in your tablet, in your cell phone, in aircraft and robots, in home appliances, data storage centers, and so on. There are microprocessor chips, there are memory chips, and most importantly, there are video display chips, as well as those that control wireless connectivity between you and your devices. There are semiconductors that are non-silicon that are used to build solar cells that power satellites, laser diodes that are used in optical data storage and communications, in medical applications, in LED lighting used in solid-state lighting, in your TV displays, remote sensing devices or radar, and power electronics in the high-voltage electric grid. Most of those semiconductors are not silicon, and over time, those non-silicon semiconductors are being integrated with silicon to create the next generation of ICs, or integrated circuits. In fact, if you pull out your cell phone and look at your screen is really that early stage of the next generation, which consists of a system of micro LEDs that are controlled and integrated with silicon CMOS electronics. So you can touch your screen and control what you want on your phone. Turns out that semiconductors are also the essential building blocks of emerging technologies such as artificial intelligence, cloud computing, 5G, the Internet of Things, large-scale data processing and analytics, and supercomputing. So really, we're kind of deep into the semiconductor age, and it's getting deeper every day. Semiconductors are really a source of so much innovation and innovative potential. For example, much of the growth that's happening right now is happening because of the need for chips in electric vehicles. Today, an advanced EV will have about 4,000 chips in it, whereas only a few years ago, this car was lucky to have a few chips, if any. With the arrival of Intel fabs in Central Ohio and the historic presence of the automotive industry in Central Ohio and all around Ohio, the synergies between electronics and transportation and mobility start to become obvious and blur together. I believe this is going to open up a major set of opportunities for Ohio State in the region. I want to share a viewpoint that I think will provide interesting perspective on the significance of semiconductors in human history. So a few years ago, The Atlantic published the results of a survey about the top innovations since the invention of the wheel. There was a large panel of scientists, historians, and technologists. So number one, since the invention of the wheel, was the printing press. Number two is electricity. Number three is penicillin. And number four is the semiconductor chip. Ahead of eyeglasses, ahead of paper, and the steam engine.
I mean, think about that. That's amazing. Okay, penicillin, saving lives. Of course, the printing press, electricity. But really, the semiconductor chip?
It's because semiconductors are part of our everyday lives. Imagine what would have happened during COVID were it not for computer-based communications, after all. The primary reason for the U.S. government CHIPS Act is to address the influence of chip shortages on many of the goods and services that we take for granted. And many of us are well aware of these issues and challenges. Because of the pervasive impact of semiconductors, they are oftentimes now being referred to as the new oil.
I hear semiconductors, microprocessors, computers, and I think a lot of people think that that's what it is. But you're saying it's basically electrical vehicles, washing machines, cell phones, televisions, medical applications, airplanes, and basically anything that we touch is enabled because of the semiconductor industry, which is kind of overwhelming, I think.
That's exactly right. It's a downstream impact of these enabling platform technology. I read another interesting report that said the average American adult today uses semiconductors 12 hours per day, to give you an idea of what you just said being so true.
You know, if I think about this, I mean, Intel's arrival here, it seems really important. Why Central Ohio?
With the presence of a major university like ours, like Ohio State, as well as many other colleges and universities that feed workforce, I think it was a natural, location for Intel to do this. And after all, why not build here where we can basically, are the center of the country, we can transport and connect with all across the United States so easily. But it was really cool to see the state government, the local governments, Jobs Ohio, many companies, community colleges, all working together to make this happen. And I think, as everybody has been saying, in Ohio, it is true that this will transform Ohio forever, and especially Central Ohio, because I think, as I mentioned before, this puts Ohio right dab in the middle of the largest, most impactful, innovative industry on the planet today. And so I actually think the Silicon Heartland is actually a great moniker for this. We have the opportunity to build our own multi-generational innovation ecosystem here. And as a university professor and also a father of four, I can personally attest to how impactful this will be for families, communities, and universities. Just the ability to keep talent and the opening of these opportunities for our kids is a huge deal. And I think that is really just thinking about the output of academic institutions. If you look more broadly, there's going to be an entire semiconductor ecosystem that's going to form due to Intel fabs here. And it's already starting. So you had mentioned the 3,000 jobs at Intel, and there's 7,000 construction jobs. What oftentimes people don't talk about is the presence of all the supply chain companies that are already moving to Central Ohio to not just feed the Intel fabs with new equipment, with new designs, and new circuits, but also to take advantage of that ecosystem. And all of these companies are going to be filling jobs. Okay, so it's much more than Intel fabs. It is really an ecosystem. Okay, and I think that these companies are going to be hiring from, as I said, from trade school, community college, all the way through to PhD.
So basically, it's an ecosystem.
It's a total ecosystem. It's a city. When you listen to the way Intel talks about its facilities at other locations, they don't talk about the factory, the facility. They talk about their entire community.
Thinking about the investment and the Silicon Heartland and the semiconductor industry, you and I lead two projects with amazing teams across Ohio with different universities. We received Intel funding, Intel grants. I mentioned that before. They are both focused on talent development, but yours delves into research too. So tell me a little bit more about the Center for Advanced Semiconductor Fabrication Research and Education. Okay, I know that's CAFE, which sounds so much more.
We're just a bunch of baristas. So sure, absolutely. So, Ohio State, as you well know, as the Dean of Engineering, super strong research university. We've been doing research in semiconductors for years, and we've been working with Intel for years, okay? So when this opportunity came around, when Intel funded the program. I think they call it the Semiconductor Education and Research Program for Ohio, SERP. We saw the opportunity, because that's really more about, as you pointed out, talent development for Intel fabs in Ohio. We saw the interesting opportunity to leverage our more historic research strength in this area with the needs of talent development, experiential development at Ohio State. So we purposefully integrated a significant experiential learning component with cutting-edge research that more or less holistically integrates undergrads not only from Ohio State, but from 9 other partner universities and 4-year colleges with graduate students, okay, from day one. So our goal was to produce both well-trained graduates from the PhD to BS, but all of whom experience the kind of training that leads to future semiconductor advances at all levels, so not just the PhD level. So to catalyze this, we started our own internal research experience for undergraduate education, or REU program, in conjunction with an organization called the 5 Colleges of Ohio. So we're basically pulling in and working with, and I think you are too, these 4-year colleges to basically give their undergrads a taste of research, but also to kind of inform them of what their careers could be like in industry, whether or not they wind up going to graduate school. Our goal is to connect the REUs from this program to the manufacturing internship opportunities in Intel fabs, which will largely be in Ohio. But we're also making a very unique program, and I haven't seen this anywhere else in the U.S. And we're calling it, for lack of a better phrase, the Industry Experience for Graduate Students, or IEG. So kind of like taking an inverse of the REU, where you have an undergrad student learning about research, here we're taking PhD students and wanting them to learn about how do things work in industry while they're getting the PhD. So basically, these graduate students will be doing summer internships at Intel labs or Intel fabs, labs being the research arm of Intel. And we think this will provide a great industry perspective to those grad students to kind of mature them about where they will wind up going. Because as we all know, most PhDs do not go into academia. And so it's really good for them to understand this. And it's really good for Intel to get the first look at these talented students for their own hiring purposes. So this way, we're kind of synergistically working together. These cohorts of undergrads and graduate students are working across the CAFE research program, which is broken into 3 research themes. The first theme is focused on next generation memory and logic devices that are using what are called 2-dimensional semiconductors. The second focuses on power management on chip using what are called wide bandgap semiconductors. And the third focuses on photonics integration for future high-speed, low-energy interconnect technologies. Overall, what we're trying to do is to kind of bring Intel as sort of co-advising these cohorts of students from day one to basically create a much more integrated and synergistic program with Intel. And that's sort of how we're doing things differently than a conventional research program. The students on it already love it because they're getting connection to people they never would have normally been able to until after 3 or 4 years of graduate school. Ayanna, you had mentioned you lead a program. It's called the Ohio Partnership for Diverse and Inclusive Semiconductor Ecosystem and Workforce. What does it set out to accomplish?
I truly believe that as engineers, we need to be much more broad-minded. And I love Ohio State. We have nearly, 11,000 students in the College of Engineering alone. But the fact is we cannot produce enough talent just at Ohio State for the semiconductor industry. And so the grant is really a partnership with other Ohio universities to figure out how do we have shared curriculum? How do we grab what we consider non-traditional students to consider semiconductor? They don't have to be electrical computer engineers. They could be chemists. They can be physicists. They can be an individual who's an architect. And so it's really trying to figure out these pathways so that we can rise to the level that we need to really provide the talent. Because at Ohio State, we can give a little bit, but we need a lot of help from our partner institutions to ensure that we do it right and are inclusive for all of the demographics that are here in Ohio, the Midwest, and of course the country.
And in fact, I think our programs are actually working together to support each other because I think I'm a big believer in this education through research phrase. And I think that there's an opportunity to do this and to democratize this across all of these components that you're talking about. And so looking very much forward to sharing the research facilities and capabilities with your curricular plans that I'm also aware of. So that sounds fantastic.
Oh yeah, some of our faculty
Yes.
overlap between the two.
Yeah, absolutely.
So thinking about this and looking ahead, You know, when a company says that they're going to build a $20 billion plant in central Ohio, they're not investing this kind of money unless they plan to stay and grow even more. So how will Ohio State help Intel succeed, you know, not in just the 5 years, but in the 10, the 20, the 50 years? What is it that we really have to think about so that it is a permanent structure that lasts forever and ever as long as semiconductors are semiconductors?
Right. Well, that's a great question. And actually, we've thought a lot about this. So, first off, Ohio State intends to be Intel's most valuable university partner in the nation, period. And we have the fortunate opportunity to be watching what has happened with other areas around the United States where Intel has partnered with other universities. So we've been actually deliberately listening, watching, learning, communicating with all those communities to see where we saw that the most value, the most important programs and interactions they had, and also to see kind of peek into the future. Well, what could we do now, watching what's happened at another location, that could be better, be different, be differentiated? To do that, we've been, as I said, studying and visiting, but we've also started to bring in and identify various folks at Intel to bring them onto various advisory boards to give advice. I think you're looking at some as well on educational programs, and we are too on research and innovation. We're working super hard to scale the size of both our education and research programs and attract more students, especially undergrads, from a very wide, diverse set of programs. This, again, part of the program you're running is focused on that. So I think that this is going to allow us to have this long-term relationship. I think that's going to be a win-win all the way around. There are things that are happening now that are more at the micro level that as a university we're already doing, and you're doing it as well. We're developing curricular plans for certificates, for minors. Okay, we're trying to find ways to open connections with other universities. So I was one of the folks that helped to form the Midwest Semiconductor Network that you're aware of. And one of the goals of that wasn't just research. It was, well, how do we address the thousands upon thousands of people needed by sharing access to facilities? So our students and say students from another university can basically utilize both. And we haven't really cracked that nut yet, how that will work, but there's all kinds of intention to do this. So I think that what we can bring to the party to make this worth decades of partnership is to basically be the connection point toward all these capabilities in our region and in the university. They're not just say, I'm going to train a student to learn how to process a semiconductor chip. It's going to be more than that, much more than that. So it gets to your point about ecosystem. That's what we're after. It's the whole innovation ecosystem, providing this big array of education and training opportunities on behalf of Intel.
So Central Ohio is quickly becoming a technology hub thanks to substantial investments from Intel, Amgen, Amazon, Honda, and more. A big draw for these companies is the top-tier talent that Ohio State prepares for the workforce of tomorrow and our commitment to innovation and collaboration. Thank you, Steve, for all that you've done to enhance our partnership with Intel and for sharing a little bit of your time with us today.
Thank you very much for interviewing me, allowing me to be here today. It's a pleasure.
If you like what you heard and are interested in learning more or suggesting your own topics for Enginuity, be sure to connect with us on social media at OSU Engineering. Thanks for listening.